let's do a function of curve sketching with a rational function. And of course, if we're looking at this one to see about the domain, the first thing being to find the domain, we need to look at that denominator because we don't want to have a denominator equal to 0. So of course that would be factored. The denominator would be x minus 2 and x plus 2. So that means our domain can't include negative 2 or positive 2. So let's see, it's going to be not fit well on that space. So I'm going to start back here a little bit. And then it'll go from negative 2 to 2 and from 2 to infinity. So that'll be our domain. Our asymptotes, of course, also deal with that denominator. So our vertical asymptotes, we know we're going to have a vertical asymptote at 2 and negative 2. But notice this one also has a horizontal asymptote. Just like when we looked at limits, we're going to look at that numerator as 2x squared as the highest power, denominator is x squared as the highest power. That reduces to 2. So we've got a y equals 2 for our horizontal asymptote. For the intercepts, the x-intercepts are going to be where y equals to 0. So that would mean our numerator would be equal to 0. So that would be, where would 2x squared minus 18 be equal to 0? So I'll factor out the 2. And then that leaves us with x minus 3 and x minus x plus 3. So our x-intercepts are at 3 and negative 3. And our y-intercepts would be where x is 0. So if I plug in a 0 into the function everywhere there's an x, I end up with that minus 18 over minus 4. And we can reduce that down to 9/2. Might be easier to keep up that with that value. So our intercept 0, 9/2. Now we need to take the first derivative. And I'm a little bit worried about space. I hope I can fit this in here. Let's do the derivative of that function, which would of course need the quotient rule. Maybe I'll just use this line as the line for the fraction. So let's do the bottom times the derivative of the top minus the top times the derivative of the bottom. And this is our line for our fraction. Let's see if I can continue that. And over the bottom square. So I hope this is not too hard to read. That x squared minus 4 squared on the bottom. Now if we set that equal to 0 and solve it, I actually simplified this a little bit and found out from simplifying, and you should check to see if you're getting the same thing, that numerator simplifies down to 20x. And then the bottom was x squared minus 4 squared. So that means that my critical values are going to be 0, 2, and negative 2. So I'm going to put those on the number line. Negative 2, 0, 2. We don't have a lot of space here to work this, but we know we're looking at the first derivative. I check the signs to the left of negative 2, and again, I'm going to do that looking at this part. If I look at the derivative, plugging in a negative number into that function, I can see that this is going to be negative. If I check a number between 0 and negative 2, probably a negative 1, I will see that it's also negative. Try between 0 and 2, maybe a positive 1, I'm going to have a positive value, and another positive number would also be positive. So double check those values. Make sure that that's what you're getting when you put in to check for the signs. So my intervals for where it's increasing, of course, anywhere we've gotten a positive sign from 0 to infinity, and from negative infinity to 0 is going to be decreasing. Make sure that looks like a 0. Our local minimum is going to be at x equals 0. And we can check that value, put that into the function. We've already put 0 into the function. We know that that's where we have our 9/2. Our local max would be none because we don't have a spot anywhere on that number line where we go from a positive increasing function to a decreasing. Now let's take a look at the second derivative. Using the first derivative, I actually used that same simplified, again I'll show it again here, this simplified version is what I used to take the derivative. And so I used x squared minus 4 squared bottom times the derivative of the top minus the top times the derivative of the bottom is going to, of course, going to be chain rule. So I've got 2 times x squared minus 4, drop the power to 1, times the derivative of the inside, and all of that over the bottom squared. When that's simplified, I end up with minus 20 times 3x squared plus 4. And again, you should check my work to make sure you're getting the same answer in the denominator. You could stop the video and double check to make sure you're getting that simplified form. And that's x squared minus 4. That's actually to the third power, so let me fix that. For the bottom. Yeah, because I made a mistake over here too, didn't I? So that was not squared, that was to the fourth power, because it was already squared, and I squared again, it should get to the fourth power. When I simplify it, that ended up one of those divided out. So now I check the number line again. When I look at those values, there aren't any new zeros. It's still the same zeros that I had from the first derivative. So I'm going to still have -2, 0, and +2. And when I check the second derivative this time, plugging into that second derivative value, then I find out that it's a negative, which is concave down, positive in this interval, which is concave up. It's positive on this interval, still concave up, and negative on this one for concave down, which means it's concave up from -2 to +2, concave down from -infinity to -2, and from 2 to infinity. And the inflection points that show up here are at -2 and +2, but they're undefined. So I actually, on my paper, I put at -2, +2, and then I said, okay, but those are undefined. So I didn't want to ignore the fact that I saw that concavity change, but those values are going to be undefined and won't give us an inflection point. So let's see what we can do to sketch this function. I know it's hard for you to see when I do the video because it's hard to see all of the paper at one time, but you go back and pull up your paper and look at the values that we've got for this function, and let's see about what we're going to mark on here. We know we've got asymptotes, +2 and -2. We know we have a horizontal asymptote at y equals 2. I know that before -2, on the left side of -2, this function is decreasing and concave down. On the right side of +2, I know it is increasing and still concave down. The interesting thing is what happens in the middle. You'll notice we already know that our y-intercept is going to be at 9/2. So let's say that's the point 9/2. So we've got a point on this function right there. And according to, let me make my asymptotes bigger. According to the function, it says that we are decreasing and concave up until we get to that point. And then we are increasing and concave up after that point. And that gives us the function we need for 2x squared minus 18 over x squared minus 4.